This is episode 34 of our Chinmaya Algebra series, and for this video, we're looking for the value of 1 minus a squared times 1 minus b squared given this sum of two radicals. This question is actually very similar to the problem in episode 2, so I suggest you watch that as well. So for this one, same with what we did in episode 2, we let x equals the square root of a squared plus ab plus b squared, and y equals the square root of a squared minus ab plus b squared, such that the given equation is actually equal to x plus y equals 1. We can multiply this equation by the conjugate, so x plus y equals 1, multiply by the conjugate of x plus y in terms of the radicand, that's x minus y. So the left side would be x squared minus y squared, and the right side becomes x minus y. Now x squared minus y squared is equal to this thing, but we remove the square roots because we're squaring it. So that's basically a squared plus ab plus b squared minus a squared minus ab plus b squared equals x minus y. We simplify the left side by cancelling out common terms. We have here cancelling out, the b squared cancelling out as well, to leave us with just 2ab on the left side. Therefore, x minus y is actually equal to 2ab. So from here, we have a system of two equations and two unknowns in terms of x and y. X plus y equals 1 and x minus y equals 2ab. We can add these two equations to get 2x, because the y's would cancel out, equals 1 plus 2ab. Now, if we substitute back the expression for x, we get here 2 times the square root of a squared plus ab plus b squared equals 1 plus 2ab. Now, this is still a radical equation, but it's better than the original equation because it only has one radical. So for this one, we'll do it on another page. So to solve this radical equation, what we will do is we will square both sides. Square this, square that. So the left side would be 4 times a squared plus ab plus b squared. You only cancelled the square root again. Then the right side would be the square of a binomial. So that's the square of the first term plus twice their product plus square of the last term. So we simplify the right side as 1 plus 4ab plus 4a squared b squared. Now we distribute the 4 on the left side because we have here a common term that is 4ab on both sides, so we can cancel that out. So we are left with 4a squared plus 4b squared equals 1 plus 4a squared b squared. We combine everything on just one side. Let's say we put it on the right side. 1 plus 4a squared b squared minus 4a squared minus 4b squared. The left side is 0. Now this actually can be factored. Even if you don't know that it can be factored, you might as well try to factor it, because if we go back to the required expression, it's something that can somehow be factored. So we factor this out. The only unfortunate thing about this is we have 1 here, which complicates things. So we we'll try to set that aside. So it will be 1 plus 4 times a squared b squared minus a squared minus b squared. And this can be factored again, this one, by um, making use of the required expression. Actually, I'm familiar already with this form, but I'm coming from the perspective that what if you are trying to solve this from scratch. So if you are not familiar with this form yet, what you can try doing is go back to the required expression, which is 1 minus a squared times 1 minus b squared. If we expand this, we get 1 minus a squared minus b squared plus a squared b squared, which is very similar to this one, except that we're missing the one here. Therefore, we can write this expression here as 1 plus 4 times 1 minus a squared, 1 minus b squared, but we have to subtract the 1. Okay? So we put this here. Let's just consider this thing here as, let's call this, let's say, m. So that we have the expression 0 equals 1 plus 4 times m minus 1. And the only thing left to do is to solve for m. So put the 1 on the right side to make it negative 1 equals 4 times m minus 1. Divide both sides by 4 to get m minus 1 equals negative 1/4. Add 1 to both sides to get 1 minus 1/4 on the right side. And so we get here m equals 1 minus 1/4 is 3/4. Therefore, the expression we're looking for is equal to 3/4, and that's our final answer. So again, the important trick that we did here is to rewrite this one in terms of x and y. And by doing that, we can afterwards multiply it by x minus y. And the x minus y is the conjugate of the x plus y. So this method, I personally call it the conjugate method. It works for several types of problems involving radicals. So if you spot a sum of two radicals, I suggest that you try making use of this method. So I hope you learned something from this video. Thank you for watching, and please subscribe for more content.